Chapter 7.3 Graphs of the Real-World Situations. Vocabulary for this section, we have some vocabulary that should look familiar to most of us. Dependent and independent variables. As a reminder, a dependent variable lies on the y-axis. It depends on another variable. We've looked at things such as the height of a person depending on their age, or the cost of something depending on the cost of renting a bike or a boat, depending on the time that you use it. Independent variables are on the x-axis. Their values affect the values of another variable. Probably the most famous independent variable is the variable of time. It is continuous in all circumstances and usually is independent of, let's say, a person's height, in the example we used before, or a lot of times distance is measured over time. Those different types of things. Time is a very common independent variable. It's not, however, always an independent variable. Linear and nonlinear. A linear would be a graph in the shape of a line. We've looked at a lot of these types of relationships, linear relationships with constant rates of change. Nonlinear being just that, and a graph that does not have a constant rate of change. It is in the shape of a curve. It might increase and decrease. It might change directions, and that's fine. It is just not constant is what we're looking at there. And we've looked at a couple different types of nonlinear relationships. We'll continue to look at some more throughout the year. Increasing and decreasing, we read these two like a book from left to right. If your y values are increasing from left to right, meaning they're going up, then you have an increasing relationship. If your y values are decreasing from left to right, you have a decreasing relationship. And that might be a curve, or it could also be a line. It could be linear or nonlinear. Either way. Continuous or discrete, these might be new to some of us or most of us. Continuous is that there are no breaks in the domain or range, okay? Meaning these four that I just drew here would be continuous. There is no break. Our line or our curve continues throughout the graph. Throughout the domain and range. So let's say maybe you're looking at a graph here of a person's hair length after a haircut. Okay, your hair is going to grow at a continuous rate throughout the time until you take another, or you have another haircut. We measure length, and we can break those measurements down. You can measure the length of your hair in feet, in inches, in half inches, in quarter inches, in 1/16 of an inch. Those things can be broken down and therefore are continuous. You can always have a different measurement of your hair at a different time. Discrete relationships, however, have breaks in the domain or the range. Most commonly here you look at things that are not able to be broken into parts, such as like people, items, animals. If we were looking at a graph here that says time that takes to clean your room, and let's say, well, this would be an example where time would be a dependent or would not be an independent variable here. Let's say time in hours. It takes 1 hour for you, one person, to clean your room. Okay, and so if, let's say, you get your brother or your sister to help you, you have 2 people, and hopefully there's no fighting or arguing, and you both do the same amount of work, and it takes half the time, so it takes a half an hour for you two to clean your room. And let's say you get a third person, maybe another sibling or a parent, to help you out, and it takes a third of the time to clean your room. All right. Now, these 3 points represent 3 different times where you'd clean your room, and it would take a different amount of time each time. If we were to connect these 3 points with a curve or a line of best fit, that wouldn't really make sense for us, because this point here, if we were to come up to the line, this point would represent a person and a half, or 1.4, 1.3 people, which is not possible. So we call that a discrete relationship, where really this graph should just be looked at with these 3 points, or a continuous amount of points depending on how many people you have helping you to clean your room. So that's our vocabulary. Let's go ahead and look at an example here. We are asked to describe this graph, telling how the quantities in the graph relate to each other. So we can do that in a couple different ways. First of all, let's try to use some of our vocabulary from before. I noticed that we increase and that we decrease. So we're doing both of those things here. We can kind of break this down a little bit and talk about the intervals in which we do increase and in which we decrease. So we can talk here about from the x value of 0, so when x is greater than or equal to 0, until x is equal to 3, or until we reach this 3 mark here, we're increasing, right? And so then another interval here from when we leave from 3 and continue until 4.5, so until 4.5 there, we are decreasing. So we can talk about that change too. If we want to be a little bit more specific, we can talk about, I see another influx here at 1.5. It looks as though from 0 to 1.5, we're increasing at an increasing rate, meaning the amount we're increasing increases as we go along the graph. So we increase this short amount, and then a larger amount, and then even a larger amount. And then from 1.5 to 3, we're increasing still, but the amount that we're increasing here, if we look at these different intervals, seems to be decreasing similarly to the amount we were increasing here. So we're increasing at a decreasing rate until 3, and then from 3 to 4.5, you see a line which represents a linear relationship, which represents a constant rate of change. So we are decreasing at a constant rate from 3 to 4.5 on the x variables here. And notice that we've talked about the differences, the relationship between the graph, how it is changing, how they relate to each other, without really even knowing what our variables are. We have no labels here to tell us what x was, what y was, but we were still able to talk about the graph and what it is doing. So for class, we'd like you to try that on your own. Here we do have some variables. This graph represents the depth of water in a leaky swimming pool. You're asked to describe the graph using 4 or more of the vocabulary words in your note sheet or that we discussed above, and then bring your answers to class along with any questions that you have from the video. See you then.